Hello, good day viewers. In this tutorial, we are going to find a solution to this amazing exponential logarithmic equation. We are given that log of x plus 1 raised to the power of log of the square root of x is equal to 1. And we are looking for that real value of x that will make the left-hand side exactly equal to 1. All right, let's get started. I'm going to present you two methods. Let's start with the first one. In the first method, I would like to take log of both sides. So we have log of the left hand side, which is log of x plus 1 raised to the power of log of square root of x, and this is equal to log of 1. You know log of 1 is equal to 0, and according to one of the laws of logarithm, this exponent can drop down to multiply. So we have log of the square root of x multiplied by the log of x plus 1. This is equal to 0, right? And since we have two factors multiplying each other and the result is 0, it implies that either log of the square root of x equal to 0 or log of x plus 1 is equal to 0. Now let us solve them separately. Starting from the first one, from definition, naturally this log has a base 10. So this 10 raised to the power of 0 will give us the square root of x. And 10 to the power of 0 is 1. So we have this to be equal to square root of x. Square both sides in order to eliminate the square root to the right hand side. 1 squared is 1, and square root of x squared is x. And hence, x equal to 1 is a solution. We are going to test it back in the end. Let's come back here, apply definition again. This has a base 10. So this 10 raised to the power of this 0 will give us the argument log of x plus 1. And 10 to the power of 0 is 1. This is equal to log of x plus 1. Finally, apply another definition because this has a base 10. So therefore, we can say that 10 to the power of 1 is equal to x plus 1. And 10 to the power of 1 is 10. This is equal to x plus 1, which we can subtract 1 from both sides, right? So we have 10 minus 1 equal to x. And finally, x equal to 10 minus 1, which is 9. So we have two solutions. Let us check and see whether these two solutions are true or not. Our equation is log of x plus 1 to the power of log of the square root of x. We want to show that this is equal to 1. So we have two values. When x is equal to 1, we have log of 1 plus 1 equal to 2 raised to the power of log of the square root of 1. You know that square root of 1 is 1, and log of 1 to any base is 0, and any number raised to the power of 0 will give us 1 except if the number is 0, and definitely log of 2 is not 0, and hence this will definitely give us 1. Then the second one, when x is equal to 9, we have log of 9 plus 1 equal to 10 raised to the power of log of the square root of 9. Let's start from the base. This naturally has base 10. A log of any number having the same base as the number will give us 1. So this is the same thing as 1 raised to the power of log of the square root of 9, or log of 3. And this is definitely equal to 1 because 1 raised to the power of any real number will give us 1. And hence, we have confirmed that x equal to 1, x equal to 9 are the solutions. Let me show you another alternative. In the second method, I would like to remind you about something. If you have a raised to the power of b and this is equal to 1, it is either if b is equal to 0, which is the exponent, or you should know that in this case, a, which is the base, cannot be equal to 0. So any number to the power of 0 is 1, except if the base is 0. Then secondly, you should know that if the base, which is a, is equal to 1, irrespective of what the exponent is, we're still going to get 1. And lastly, if the base is equal to -1 and the exponent is even, it is even number, then -1 raised to the power of even number will still give us 1. So now let us apply these three conditions in solving this problem. Let's start with the first one, which is when the exponent is 0 and our exponent is what? Log of the square root of x. So number one condition, when log of the square root of x is equal to 0, it implies that 10 to the power of 0 is equal to the square root of x, and 10 to the power of 0 is 1. This is equal to square root of x. If you take square of both sides, you have x equal to 1. And second condition, and you can even test it. Already we have tested this in our first method. We don't have to do it again. And secondly, when a, which is the base, is equal to 1. And what is the base? Is log of x plus 1. So second condition, when log of x plus 1 is equal to 1, we have 10 to the power of 1 equal to x plus 1. 10 to the power of 1 is still 10. We can subtract 1 from both sides, so we have x equal to 10 minus 1 and x equal to 9. We have already realized this solution initially. Then the last condition is when the base is equal to -1. When we have log of x plus 1 to be equal to -1, so we have 10 raised to the power of -1 to be equal to x plus 1. 10 to the power of -1 is 0.1. This is equal to x plus 1. Subtract 1 from both sides. We have x equal to 0.1 minus 1. And finally, x equal to -0.9. Another solution, but this one we have to test it. If x is equal to -0.9, remember our equation was log of x plus 1 raised to the power of log of the square root of x. This is equal to 1. Already we have square root of x here. And if you take square root of a negative number, you're going to get a complex solution. And hence we are going to discard this. Remember, we are looking for real solutions. Therefore, we are not going to consider x equal to -0.9 as our solution. Rather, we conclude that x equal to 1 and x equal to 9 are said to be the solutions to this problem. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.